to my channel on Introduction to Pytorch. In this video, we will talk about how can we train a simple linear regression model in Pytorch. We talked about what is linear regression, and we also demonstrated an example of linear regression in last video. We will talk about how we can train or program a linear regression model. Now, in order to get started, we first of all need to do the building blocks. So we will first of all write a class, and I'll call linear regression model, and we will use the NN module to inherit the basic functionalities which we'll need to define this class. I will then need to define the init function. For that, I will call and then I will pass some parameters like the input dimension and the output dimensions. In the case of linear regression model, the input dimension and the output dimension will be set to 1 because we have one dependent variable and one independent variable. Let me just quickly inherit this. Call the init function on it, and let me just pass the self module so that it can do its operation. I will then define a linear layer from the NN module, and in order to define that linear layer, I will pass input dimension and output dimension. I will then define how will the forward pass of this network will look like. So this network will receive X as input, and it will return it will apply the linear layer over that input, and it will simply just return that after applying that linear layer. I will then define the network. So in my case, the input dimension is set to 1 because I'm using a single dependent variable and single independent variable, and I will have output as also set to 1. I will then define the model because these are the two inputs which we need for the model. So I will pass input dimension and output dimension. I will then define a criteria for this model to train. So in order to define that, we can use mean squared error loss from the neural network module within the torch package. Then I will need to define a couple of other variables which are important to train a neural network. So the first variable I will define is the learning rate. So I can set it to 0.01 here. And I can then need to define an optimizer which will be used to track the parameters of the model and also to compute gradients of the model. Now to do that, I can again use the NN module within the torch package. No, actually you can also use optim module, which is the optimizer module, and you can find there is a optimizer called SGD, and then you can pass various parameters which are required for this optimizer to work. So the first parameter you will need to pass is the set of parameters of your model, and the second parameter which you will need to pass is the learning rate, which we are going to use for training this network. We will then need to define the number of epochs we are going to train this network for. So let's say let's train this for 100 epoch. So now the boilerplate stuff is done. We'll now need to generate some random data. So I will use a very simple data for this network. So I will simply just use range 20. So I will just take my x-axis in the range of 20. So everything from 0 to 19 will be on my x-axis, and I'll just simply convert these values to a NumPy array so that they are prepared as an input for my torch model. And for that, you can simply convert them into float 32 and reshape them so that your network can receive one input as an input and receive one input as an output. We need to do this reshaping for the output variable as well. Now to compute the output, what we can do is we can apply a very simple function. So for example, we can say that each value of my variable is defined by this function, which is and within the range of x value. So, and again I need to change the d type so that it's in accordance with the d type which is required from the Pytorch package. uh, I also need to reshape this value so that it looks similar to the shape of my input variable. And now we have the input and our outputs which we can use for our network. Now in order to train the network, we have to first of all generate a for loop. So for epoch and epochs, and then we have to go step by step. So the step one will be that we will first of all take our inputs and we will first of all pass them to the torch package. So until this point, torch package or the Pytorch package doesn't know that how can we compute or how can we use this input directly. So we first of all have to specify that these are our inputs. So in order to do that, you can say torch from numpy and you can pass your value, which is xtrain over here. And because we want to track the gradient, we'll need to pass requires gradient and set it to true. We'll need to compute the labels. Again, for that we have to pass the same function part from numpy and we have to pass the values we have computed from the y. We'll then need to apply set the gradient or the optimizer cache to null or clear the optimizer cache so that it can compute a new set of gradients. We will then need to compute the outputs of our model. In order to do that, we will pass the inputs which we have computed in the previous step to the model, and this will do a forward propagation over the model and compute the outputs of the model. We will then compute the loss. In order to do that, we'll pass the outputs which we have computed in the previous step and pass the labels or the ground truth which we have over here. Now once the loss function is computed, we can do a back propagation over the loss function. We can do a backward pass and then do an optimizer step. Now after each step, essentially what should happen that your loss will start from an initial higher value, but eventually it will start going down as we are training the model and the weights are getting learning. So we can print for each epoch what is the loss our model is computing. So now let's say we run this function. So you can see it's printing the loss function. Now if you slightly want to see the exact loss function, instead of looking at all the tensor and all this, you can simply say loss dot item. That will give you the exact value of the loss instead of, so I'll clear this thing. So now you can see like how the model is learning. Initially your model is doing pretty badly, but as we are going down and down, it's doing some sort of learning. But looks like here it's overfitting. We'll see in the later set of tutorials that how can we resolve these sorts of issue. But this is the general recipe which you can use to train a simple neural network. I will quickly do an experiment to see if I slightly lower down the learning rate, what will happen. And as you can see, your model is doing a reasonable job now. So it's starting from a higher value of the loss function and then gradually going towards a reasonable value of the value. Earlier with the very high learning rate, it was, I think it was completely overfitting. So that's the tutorial on linear regression. In the later set of videos we will talk about more advanced networks. So please subscribe to my channel in case you are interested in this topic, and please, thanks for watching this video.